Let's take a look at this problem. Um, in advance, it's a measurement problem. It might be classified as a geometry problem because measurement is considered a subset of geometry, even though it's really more like scientific measurement and rounding and so on. Um, the measurement of length is maybe the root of geometry, which is another reason the two topics are connected, at least for praxis studies. So here we go. We've got Jane going shopping, rounding to the nearest dollar, right? That's rounding, it's measurement. So as I said, could be considered part of geometry. She bought 17 items and estimated the total to be 64. So that must be after the rounding. Find the price range for the actual total cost. Price range for the actual total cost. So what we've got is an estimate, and from that estimate, we have to figure out the lowest and highest actual costs. Now, 17 and 64, they're kind of big numbers, and I kind of get intimidated when I think of adding 17 things, each of which has been rounded. So what I can do is I can simplify the problem. That's a that's a classic math problem solving strategy. Simplify the problem, see if you can solve it in a simple case, and then see if you can generalize it or at least push it up to a little bit more complex numbers, but the idea will remain the same. So let's just knock a lot off of this. Let's just go 2 items and let's pretend it's, I don't know, $5 as the estimate, right? Let's do a $5 estimate, right? What we're trying to do is simulate the same problem and but do it in a much simpler context. Find actual, right? We got to find the range of actual prices, right? We've estimated and lost the originals, so we don't know the actual, but we can figure out a minimum and a maximum for the actual. So let's just take an example. If we have 2 items and we're rounding to the nearest dollars and it added up to 5, why don't we just, item A rounds to 2, right? The rounds to 2, RND, round to 2, and let's pretend B rounded to 3, all right? Well, what's that mean about the original prices, right? The real price of the thing that rounded to 2, the very smallest could have been $1.50, and the very largest could have been $2.49, right? That's the maximum price that would round down to 2. And then for the $3 item, again, we know the real range. The real range is $2.50. That would round up to $3, but it could have been as expensive as $3.49. All right. So when we have 2 items, and the estimate is 5, the minimum, right? The minimum would be the sum of $1.50 and $2.50. That's 4. And the max would be 2.49 plus 3.49. That's effectively 6. It's really $5.98, right? We don't have money like 0.499999 right? Almost $2.50 ends a penny short. So if you want, you can think of this as $6 minus 0.02, right? I'm shy 2 cents because I've got 2 items and I'm rounding to whole pennies. And now we can add another, right? Add a C, make it 3 items, make that, $8. Okay, that means there's, fine, make it $18. right? That means the third, it could have been 6, 6, and 6. It could have been 2, 3, and 13, right? It doesn't really matter because these things are going to add up to 18 no matter what. And then each one of these is going to contribute a downward negative 50 cents or an upward 49 cents. Each one, right? If there was three, it would have been, if it was three things adding up to the same $5, let's make it simpler, then it would have been maybe 2, 2, and 1. And that would have been a 1, that would have been a 1, that would have been a 0, that would have been a, that's still a 2, that's a 2, this is a 1, right? But the goal is there's another 0.50 because of third thing. There's another 0.549 because of a third thing. The up, right, and the down from that middle number. Every rounding contributes down 50 cents to up 49. And if you have 17 items, now we can generalize the idea, right? If we have 4 items, up and down that amount times 4. 17 items, well, just multiply by 17. Right? What's 17 times that interval? The minimum is negative 50 cents. The maximum is plus 0.49. Well, what you get is minus 8.5, and I'll write that as $8.50, back to money language. And the other end is essentially the same thing. It's really plus $8.50, except, right, it's not 50. We have to take off a penny for every one, right? We're rounding down 49. So we have 17 items, we're short 17 cents. So we gotta, right, we can't say $8.50. Instead, we say $8.43. That little bit of penny is a little annoying, but what can you do? And now finally, we had that middle cost was 64. So we have to take the 64 and modify it down that much to up that much. 64 minus 850, that's 55.50. That's the situation where every single thing was actually half a dollar lower than the rounding, right? Everybody rounded up, so the actual cost was lower. And on the other end, it's the opposite. Everything ended in a price of 0.49, 49 cents, but you rounded it off. So you, right, you underestimated by 49 cents per item. So that's the 843 plus $64. So that's 72. Oh, little arithmetic error. I apologize. 50 minus 17, not 43. 33. My bad. And there it is. Again, jumping right in with the 17 and the 64, too complicated for many people. So think it through. Maybe one thing, one doesn't really help you add up, so start with two. And just pick any example. $5, 2, and 3. See what happens. Try to avoid extremes like $1 and 4. Pick something in the middle, middle-ish, and then check it out. And then maybe try $1 and 4, two things. And maybe try three things and it's $2, $2, $2. And then try 1, 2, and $3. Very soon you'll be noticing, oh, every estimation contributes anywhere from 50 cents down to 49 cents up for the original actual cost. So every estimation, oh, 17 of them, multiply. And there it is. That's the strategy of solving a simpler problem in order to figure out how it works, the underlying guts, and then applying that knowledge on the small example to the, let's say, computationally larger example, but conceptually identical example.